Interpreting box and whisker plots. So I briefly discussed this in example 2. So if you haven't watched that yet, go back and watch example 2. If we take a look at our box plot, we've got the minimum, Q1, Q2, Q3, and our maximum. And in this box plot, when you split your data by the median and then the median of the lower and the median of the upper, what you're getting here is you're getting that this is 25% of the data. 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 They don't look the same sizes, but that's because it's telling us how spread apart they are. They have the same amount of numbers in each group, but some numbers are more spread apart than others. Okay, now if we take in this box, we've got 25% and 25%. So it's going to say, okay, well, half of the data, 50% is within the box. You could also cut it at the median. 50% is below, 50% is above. You could cut it in different places, add the percentages together. Now, we know what the range of a data set is. It's the largest number, subtract the lowest number. But then we also have the interquartile range, is where you take the upper quartile, quartile 3, and subtract the lower quartile, quartile 1. This is the interquartile range, which tells you how spread apart your data is from the first quartile to the third. Example 3. The box and whisker plot represents the time in hours spent on a project by students in a history class. First of all, letter A, find and interpret the range of the data. Now keep in mind they said range here, not interquartile range. So for the range, I'm going to take the maximum, which is 9, and I'm going to subtract the minimum, which is 1, which is going to give me 8 hours. And then we have to interpret that, which means time spent on projects, or the time spent on projects varies by no more than 8 hours. So the quickest kid spent 1 hour on their project. The longest kid spent 9 hours on their project. So there's no more than 8 hours between the fastest kid and the slowest kid. Part B, describe the distribution of the data. So in order to do this on a box plot, we're going to split it into its quartiles, and I'm going to make 4 different statements. 25% of students spent between 1 and 3 hours on their projects. That's my first statement. Then I'm pretty much going to repeat that, and then I'm going to say, okay, well, another 25% spent, and I'm going to abbreviate B/W means between, so spent between 3 and 5 hours on their projects. And then I'm going to say 25% spent between 5 and 8 hours on their projects. And then lastly, 25% spent between 8 and 9. So you just kind of tell me what's going on there. Part C, find and interpret the interquartile range. Not the range, the interquartile range. So this is where we're going to take Q3, which is 8, and we're going to subtract Q1, which is 3. So 8 minus 3 is 5 hours. And then the way we're going to interpret that is we're going to talk about the middle half, because right in here, this is kind of like the middle half of your data. So the middle half of time spent varies by no more than 5 hours. So middle half of time spent on projects varies by no more than 5 hours. Part D, are the data more spread out below Q1 or above Q3? And then explain. Well, take a look at below Q1. That would be from 3 to 1. Look at above Q3. That would be 8 to 9. Well, which ones are more spread out? Well, they're more spread out below Q1. And then how do you know? I'm going to keep this simple and say the whisker is longer. We could put numbers in there and say, well, 1 to 3 is different by 2, 8 to 9 is different by 1, but really that just means the whisker is longer.